Welcome to Review Recording 1A on the Cosine Law for Unit 2, Chapter 2 of Mathematics 2200. This recording accompanies instructional recording 1A on the same section. We'll be using the cosine law to find angle and side measurements in non-right triangles in problem-solving situations. In example 1, we're given triangle HAT with lowercase h equals 4 inches, A equals 5 inches, and T equals 6 inches. What is the measure of angle T? Now I draw my triangle. I try to match the conditions of the problem as close as I can. H is the shortest side, so that must be right here. A is the next longer side, so that must be over here. And T is 6, all in inches. Capital H on my diagram is right here. A is right here, and T would be up here. We have to find angle T. It's a law of cosines problem because we have SSS, three sides, law of cosines, or cosine law. So cosine of angle T would be equal to A squared plus H squared minus T squared, all lowercase, all over 2AH. Lowercase a is 5, so we have 5 squared. H squared is 4, so we have 4 squared there, minus 6 squared for our T squared, all over 2 times 5 times 4. 25 and 16 is 41, minus 36 is 5 for the top. And in the bottom we have 2 times 5 is 10 times 4 is 40. So that's really 1/8 when we simplify. So that means angle T is equal to the inverse cosine of 1/8, which gives us approximately 82.8 degrees. There's no ambiguous case with the law of cosines. C is our correct answer here. Example 2, a longer answer question. We have to determine the measure of angle B in this triangle. Let's see, if we try to go with this triangle ABC right away, all we know are two sides. We don't have any more information, not enough to use a formula. And likewise, if we try to work with the large triangle ABD, we still don't have enough information. So what about if we worked with ACD right here? We have a side, and a side in triangle ACD. That will allow us to find this angle, and once we have this angle here, we can subtract it from 180 because we make a straight line, BD. That'll give us an angle here by subtracting ACD from 180. I start by drawing a copy of triangle ACD over here, and I recognize that I have side, which is the cosine law. So cosine of angle C in that triangle is equal to A squared plus D squared minus C squared, all over 2AD. A is 4, so we have 4 squared. D is 3, so we have 3 squared minus C squared, that's 6 squared, all over 2 times 4 times 3. 4 squared is 16, plus 3 squared is 9 is 25, minus 36 gives us negative 11 over 2 times 4 times 3, that's 24. So that gives us cosine of angle C is negative 11 over 24, so angle C is equal to the inverse cosine of negative 11 over 24. Which gives us an angle of 117, well, we're going to the nearest degree, so 117 degrees. So that's 117 degrees there, which means in our original diagram, that's 117 degrees right there, which means that this angle must be 180 subtract 117. So angle ACB equals 180 subtract 117 because they make a straight line. and we've got 63 degrees there for that angle. So now I make a copy of triangle ABC. I've got SSA, so I use the sine law. We might think that's the donkey theorem again, the ambiguous case, except we have a diagram and we know angle B is acute. Therefore, we have sine of angle B over 3 equals sine of angle C, 63 degrees, over 5. So sine of angle B is equal to 3 sine 63 degrees divided by 5. I'll need to finish this on the next slide. So I've copied a few things over to this slide so we have our previous steps. Sine of angle B works out to be approximately 0.5346. We do the inverse sine of that. Inverse sine of 0.5346, which is equal to approximately 32 degrees to the nearest degree. Angle B is acute, so the 32 degrees does make sense. We don't need to consider an ambiguous case. Remember that the cosine law can be used in the situations where you know the two sides at an included angle or all three sides. And in some cases you may need to use one formula, the cosine law or the sine law, in one triangle to get enough information to work with another triangle for diagrams where there are two or more triangles.